Imagine a reality where every decision you make splits the universe into countless new versions of itself. You choose coffee over tea, boom! A new universe springs into existence where you opted for tea instead. Each choice, no matter how trivial, creates a ripple effect across the cosmos. This mind-boggling concept, while seemingly ripped from the pages of science fiction, lies at the heart of the multiverse theory. It's a theory that has fascinated and perplexed scientists for decades. It suggests that our universe, vast and awe-inspiring as it is just one of an infinite number of universes. Each of these universes could contain its own unique set of physical laws, constants, and even alternate versions of ourselves, living out different lives based on the choices we didn't make. Picture a vast cosmic tapestry, woven with an infinite number of threads, each representing a different universe. This tapestry is ever expanding, with new threads being added every moment. Each choice we make, no matter how small, creates a new thread, branching off into the vast unknown. These threads intertwine and diverge, creating a complex web of possibilities. In this grand cosmic narrative, we are not merely passive observers, but active creators. Our every decision, every action shapes the very fabric of reality, weaving our own unique path through the multiverse. This tantalizing idea has captivated physicists, philosophers, and science fiction enthusiasts alike. It has sparked endless debates, fueled our imaginations, and inspired countless stories and theories. Could there be a universe where you made that life-altering decision differently? A universe where you took a different path, leading to a completely different life? A universe where you took that chance, chased that dream, or said yes instead of no? The possibilities are endless and mind-expanding. The concept of parallel universes challenges our understanding of reality, pushing the boundaries of what we believe to be possible. It forces us to rethink our place in the cosmos. It invites us to consider a reality far grander and more mysterious than we could have ever imagined. A reality where every decision, every action has cosmic significance. It's a reality where the impossible becomes possible, and the boundaries of our universe dissolve into a sea of infinite possibilities. In this universe of decisions, we are the architects of our own destinies, shaping the cosmos with every choice we make. The idea of parallel universes, once relegated to the realm of science fiction, has found its way into the scientific mainstream, thanks in no small part to its portrayal in popular culture. From the mind-bending adventures of Rick and Morty to the alternate realities explored in Doctor Strange, the multiverse has become a staple of modern storytelling, capturing our collective imagination and sparking our curiosity. These imaginative portrayals, while often exaggerated for dramatic effect, hint at the profound implications of a multiverse. They invite us to consider the tantalizing possibility of other versions of ourselves living out their lives in parallel universes, making different choices, facing different challenges, and experiencing different destinies. But the concept of parallel universes is more than just a fictional device. It's rooted in serious scientific theories that attempt to explain some of the most fundamental mysteries of our universe. Theories like quantum mechanics, string theory, and cosmic inflation, while still speculative, offer compelling evidence that our universe may not be alone. These theories, born from the minds of brilliant physicists and mathematicians, challenge our conventional understanding of reality, suggesting that our universe is far stranger, more complex, and more wondrous than we could have ever imagined. They paint a picture of a reality where the impossible becomes possible, where the boundaries of our universe dissolve into a sea of infinite possibilities.
The seeds of the multiverse theory were sown in the strange and counterintuitive world of quantum mechanics. This realm, where the rules of classical physics no longer apply, opened up a Pandora's box of possibilities that continue to baffle and intrigue scientists to this day. This revolutionary theory, developed in the early 20th century, fundamentally changed our understanding of the universe at the smallest scales. Pioneers like Niels Bohr, Werner Heisenberg, and Erwin Schrödinger delved into the mysteries of the quantum world, laying the groundwork for what would become one of the most profound scientific paradigms. It revealed a reality where particles behave like waves, existing in a superposition of states both here and there until observed. The famous double-slit experiment demonstrated this duality, showing that particles like electrons could interfere with themselves, creating patterns that defied classical explanation. One of the most mind-bending interpretations of quantum mechanics is the many-worlds interpretation, proposed by physicist Hugh Everett III in 1957. Everett's radical idea challenged the conventional Copenhagen interpretation, suggesting that all possible outcomes of quantum measurements are realized in separate, branching universes. According to the MWI, every quantum measurement or interaction causes the universe to split into multiple universes, each representing a different outcome. This means that every decision, every random event, and every quantum fluctuation spawns a new universe, creating a vast and ever-expanding multiverse. Imagine a single electron, its wave function spread out, representing a multitude of possibilities. This wave function encompasses all potential states the electron can occupy, a concept that is both fascinating and perplexing. When we measure the electron spin, for example, the MWI suggests that we are not collapsing the wave function into a single reality, but rather we are splitting the universe into two. Each measurement creates a new branch, a new reality where different outcomes coexist. In one universe, the electron's spin is measured as up, while in the other, it's measured as down. These parallel universes exist simultaneously, each as real as the other, yet inaccessible to one another. This continuous branching of the universe, driven by every quantum event, creates an unimaginably vast and complex multiverse, a tapestry woven from the threads of infinite possibilities. Each thread represents a different path, a different history, and a different future. It's a reality where every quantum dice roll, every random event spawns a new universe, each with its own unique history and future. The implications of this are staggering, suggesting that there are countless versions of ourselves, each living out different lives in parallel realities. The MWI, while still highly debated, offers a compelling solution to some of the paradoxes of quantum mechanics and provides a theoretical framework for the existence of parallel universes. It challenges our understanding of reality, pushing the boundaries of what we consider possible. It suggests that our reality is not the only one, but rather it's just one branch on an infinitely branching tree of possibilities. Each branch represents a different outcome, a different version of events, and a different universe, all existing simultaneously in the grand tapestry of the multiverse. Another compelling piece of the multiverse puzzle comes from string theory, a theoretical framework that attempts to unify all the fundamental forces of nature into a single, cohesive theory. String theory posits that the fundamental building blocks of the universe are not point-like particles, but rather tiny, vibrating strings of energy. These strings are incredibly small, far smaller than anything we can currently observe with our most advanced instruments. Just as a violin string can vibrate at different frequencies to produce different musical notes, these fundamental strings vibrate at different frequencies to give rise to the different particles and forces we observe in the universe. Each vibration mode corresponds to a different particle, much like each musical note corresponds to a different sound. It's a beautiful and elegant theory, but it comes with a mind-bending twist. It requires the existence of extra spatial dimensions, curled up and hidden from our perception. These dimensions are compactified, meaning they are so small that we cannot detect them directly. These extra dimensions, beyond the familiar 3 dimensions of space and 1 dimension of time, are not merely a mathematical quirk of the theory, but are essential for its consistency. Without these additional dimensions, the equations of string theory would not hold together. They provide the extra room needed for the strings to vibrate in all the ways necessary to produce the diversity of particles and forces we observe. This diversity is what makes up the rich tapestry of the universe, from the smallest subatomic particles to the largest cosmic structures. But the existence of these extra dimensions has profound implications for the multiverse. It suggests that our universe might be just one of many, each with its own unique properties and physical laws. Some string theory models suggest that our universe is just one brane, short for membrane, floating in a higher dimensional space. These branes can be thought of as parallel universes, each existing in its own separate dimension. Just as there could be multiple sheets of paper floating in a room, there could be multiple brains, each representing a different universe, coexisting in this higher dimensional space. These brains could be incredibly close to each other, yet completely undetectable from within our own universe. These brains could collide or interact, potentially giving rise to new universes or influencing the physical laws of existing ones. Such interactions could have dramatic effects, possibly even explaining some of the mysteries of our own universe, such as the Big Bang. It's a mind-boggling concept, but one that emerges naturally from the mathematics of string theory, lending further credence to the idea of a multiverse. The more we explore these theories, the more we realize how much there is yet to discover about the true nature of reality.